Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, largest square formed in a matrix. Okay. So we'll be given a binary matrix, okay, of size n into m. And what we want to do is we want to return the maximum length of the square. Okay. The maximum length of a side of a square. Okay. So here in this case, in this example, what is the maximum length of a square? Okay, it is this square. Okay, and what is the length? 3 into 3, right? So what we want to do is we want to return the maximum length of the side. So here it is 3. We want to return 3. If you see in the output, we have to return 3. Okay, so that's what we're going to do. Okay, now how can we solve this problem? So one thing to note here is even if a cell contains 1, so it is going to be what? It is going to be, it is still a square. Okay, the length will be of size 1. The length will be of size 1 of the square. Okay, so what trick we are going to use here is, for example, let's consider for size 2, right? For size 2, if we, let's consider this particular example. So here what it is? 1, 1, 1. Now, if this in this position, if it is 1, then what we are going to do is we are going to take the minimum, the length of minimum, okay, out of these three adjacent cells. Out of these three adjacent cells, we are going to take the length, okay, the minimum length of out of these three adjacent cells. Okay, so what it is a minimum length? It is 1, right? 1. And we are going, what we are going to do for this position, we are going to add 1 to the minimum length. Okay, so what it is going to be? It is going to be 2. And right, so it is right because see, now it is a 2 size matrix, right? The size of the matrix is 2, if you see here. So that is why this one, it is correct, right? In a way, it is right. So for example, let's consider now here it became 2, right? Now let's consider, so if we have this 3 into 3, right? For 3 into 3, again, what we are going to do for this position, again, for this position, what we are going to take? We are going to take the minimum out of this 3. So what is the minimum? It is 1. And we are going to add, if here it is already 1, right? So we are going to add plus 1 here to this cell. So it is going to be 2. And yes, this also becomes a size 2 matrix, right? A size 2 square matrix, right? And this one also, if you see, it is a size 2 square matrix, right? Now again, so here we got 2. So if there is 1 again, and here in this position, if it is 1, so what we're going to do, we are going to take the minimum length, okay, from these adjacent cells, and we're going to add 1. So here it is going to be 1. Here it is going to be 1 plus 1, 2. Again, so this is also 2 into 2 matrix, right? This is also square, right? Of size 2. Okay. Now for this particular position, if it is 1 again, if it is 1 here, so what are we going to take? We are going to take the minimum, the minimum length out of these three adjacent cells. What is the minimum length? It is 2, right? And plus 1 we are going to do, which it will make it 3. Okay. So here we'll have 3. So here if you see, right? Anyways, definitely it's a 3 into 3 size matrix, right? A square matrix. So that is why this answer, it is right. Right. Okay, so we are going to use this trick. Okay, so we are going to use dynamic programming approach. Okay, dynamic programming approach, that is we are going to take a dynamic programming array or matrix of size n into m, and it will be initialized 0. Okay, so let's quickly code. This will be the intuition to solve the problem. Okay, before going to the code, I'll request you to subscribe to my channel. Thank you so much. Also, I'm going to show you the C++ code as well. Now I'm showing the Java code. Okay, new. Okay, and the size will be n into m. N is a row and m is a column. Okay, now we don't need to initialize dp with 0 because by default it is going to be initialized with 0. Okay, so what we are going to do here, int I equal to 0, I less than n plus I, right? And then we are going to have what? Again, we are going to have j for the column, j less than m. Okay, the number of columns or the column size, right? And here we have what? Okay, so what we are going to do here, first of all, if it is I equal to 0 or j, if it is a 0th row or 0th column, then what we are going to do, we are going to copy as is. Okay, if mat of ij, right, or the 0th row or 0th column, it is 1, then only we'll put 1 into the dp array. Okay, so why we are doing this? Anyways, if you see, right, the length over here, it is always going to be 1 only of the matrix, right, of the square matrix. Okay, it is always going to be 1 only. So how you are filling the dp array? So here it is, the dp array will be, so first we are filling the 0th row, right, like this, and the 0th column as is, because the size of the matrix, right, of the square, it is always going to be 1 over here. Okay, so we are copying as is if it is 1. Okay, So we are not going to copy 0 because by default it is going to be 0 only. Okay. So here, okay, we are done with this check. Now what we are going to do here, if mat of I, now if it is other than 0th row or 0th column, then what we're going to check, if it is, if some position, if it is 1, then simply what we're going to do, for example here, right? For example, this case if we consider, or let's consider, yeah, this case, right? So now in the, okay, so what we're going to do, for example, this particular case, right? Now here, this mat of I, so ij is here, right? Ij is here. So we're going to check what? We want to take the minimum length of these adjacent cells, right? So that's what we're going to do. So what we're doing here is, okay, so dp of ij, right? dp of ij equal to math dot minimum, math dot minimum dp of, okay, first the this particular column, right? This particular cell, for example, this particular cell, j minus 1. Okay. Okay, we are decrementing the column here in this case, right? Also, we'll take mat dot minimum of dp of the previous row, right? The previous row, the cell in the previous row, right? And the diagonally opposite row, minus 1 and j minus 1. Okay. So here we are doing minimum plus 1. That's what we are doing, right? So here quickly we can fill here, right? So again, if it is, so if it is 1, mat of ij, if it is 1, right? If this is the position, then what we're going to do, we're going to take the minimum length, right? What is the minimum length here? It is 0. So we are going to take 0 plus 1. 0 plus 1, again it is going to be 1 only. So in this way, here it is 0, so it will fill 0 only. Here it is 0, it is will fill 0 only. Here it is 1, we are going to take the minimum length. The minimum length of these three, right? It is 0. So 0 plus 1, it is going to give us 1. It is 0, here we will copy as is, right? Again, this mat of ij, if it is 1, we are going to take the minimum out of these three, 1, 2, 3. So it is 0 again. So 0 plus 1, we are going to fill 1 over here. Okay. Now again, for this position, mat of ij, it is 1. So here what we are doing, we are going to take the minimum out of this. We are going to take the minimum out of this, which is 0 again. 0. So we are going to add 0 plus 1, 1 here. Okay. Now again, at this mat of ij, right, it is 1. So yes. So one thing to note. So we are going to compare, right? Take the minimum in this DP array, not in the matrix, in the DP array, right? Because we are doing the calculations over here. So again, it is minimum is 0. So 0 plus 1, it is going to be 1, right? Again, it is 0. We'll copy as a 0, right? Here it is mat of ij, it is 1. So here what we're going to take, the minimum out of these three, it is 0. 0 plus 1, it is going to be 1. Now here, mat of ij, it is 1. So what we're going to take, we're going to take the minimum out of these three, right? Minimum out of these three. So what it is, minimum 1. 1 plus 1, 2. So yes, we have found a a square of 2 size matrix. Okay. Okay. Again, here it is 1. So we are going to take what? Minimum. Again, minimum out of these three. So it is 1. Again, 2. We are 1 plus 1, 2. Okay. Here it is 0. We'll copy as is. We'll copy as is. And then here again, it is what? Again, here it is. Okay. So, okay. So where were we? Yeah. So yes, so here again, what we're going to do for this particular, right? So the minimum is what out of these three, right? The minimum is what? 1. So again, 1 plus 1, 2. Okay. So again, for this mat of ij, it is 1. So we're going to take the minimum out of this. So in this way, we are going to do, it is going to be 2 here. Again, for this particular here, now the minimum length is 2. So we are going to do what? 2 plus 1, 3. It is going to be, right? Similarly, here it is going to be 1 as is, because the minimum is like this. So in this way, we are going to fill our DP matrix. Okay. So let's quickly code. I hope you've got the intuition. Okay. So here we have filled this, right? So that's what we're doing. We are taking the minimum out of this, out of the adjacent cells. Okay. Now also what we're going to do, we are going to take an answer, right? An answer variable to capture, right? To capture the maximum size. Okay. The maximum length of the side. Okay. So here what we're going to do, after this, we are going to say answer equal to math.max answer plus dp of I and j, right? dp of ij, right? And then simply we are going to return the answer. Okay. So this is a code. Let's quickly compile this. Yes, it has compiled. Let's run. Let's submit. Okay, the test cases seem to pass. I hope you've got the solution. Thanks for watching. Please subscribe to my channel, like the video. Let's quickly see the C++ code as well. Okay, so here's the C++ code. So we're going to take vector of vector as a dynamic programming array. Okay, DP array. Okay, and then simply whatever we have done, right? It's the same thing. It's the same thing, right? Only the thing is this: we have minimum function, inbuilt function like this in the standard namespace. Okay. So and finally, what we're doing, we are calculating the maximum out of the answer in the DP of ij and returning the answer again. Okay, so I hope you got the solution. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.